What's going on, everyone? Welcome back. Patrick here, and in this video what we're going to cover is actually the exact same example that we did in the previous video. So notice I have it written out again, but instead of making a histogram for this example like we did previously, I'm going to make a stem leaf plot for that exact same data. But I'm actually going to be bringing back a lot of the steps that we covered previously and show you how those steps relate to making a stem leaf plot. So if you didn't watch that previous video on this same example, highly recommend you do before watching this one. Now remember, we're still analyzing quantitative variables. And as I mentioned before multiple times, we have two tools that we can use to visually show quantitative variables. We could show them with histograms, which we covered in the last video, and we can show them with stem leaf plots, which is what we're going to cover in this video and actually in the next couple of videos. So to quickly review what we did in the previous video on this same data, was we took this quantitative variable here, which remember is the percentage of the population in each of these cities that is using iPhone. So 61% of Toronto is using an iPhone, 50% in New York City is using an iPhone, etc., etc. So we took this percentage here and we sort of made intervals for it. So 40 to less than 50, and then 50 to anything less than 60, etc., etc. And then we counted the number of cities or the frequency that fell into each interval. So between 40 to less than 50%, notice that it was Montreal and Las Vegas. So there were two cities that fell in this interval, and then three cities that fell into this interval, etc., etc. Now, this is called a frequency table. I mentioned that in the previous video as well. Well, a stem leaf plot is actually going to be very similar to a frequency table, but it's actually going to be more detailed. So if you think about it, if we look at this interval here, 40 to less than 50, that is the exact same as all percentages that start with 4. Right? Notice this is going to be always in the 40s. So we have this 42 and 49. Right? It's always starting, whatever starts with 4 is going to go in this interval over here. Then over here, whatever starts with 5 is going to go in this interval, whatever starts with 6, whatever starts with 7. So that's what a stem leaf plot basically does. So what we're going to do, the way this is shown, is instead of saying 40 to less than 50, we just put a 4 here. And then 50 to less than 60, we would just put a 5. Then 60 to less than 70, we would just put a 6. Let's make this line a little bit more straight. 70 to less than 80, we would put a 7. 80 to less than 90, we would put an 8. And then 90 to less than 100, we would put a 9. And then what we do is, instead, over here on the right side, instead of putting the frequency, so we wouldn't put like 2 here and 3 like we did over here, 2 cities that fall into this interval or 3 cities that fall into this interval or start with 5. What we do here on the right side is put the other digit, the last digit. So notice with Montreal, it starts with a 4, last digit is 2. So we would put a 2 here. And then the other city that started with a 4 was Las Vegas. Last digit is 9. Like that. And so that's why it's more detailed, because instead of just saying that 2 cities fall in this interval, like the frequency table did, we specifically know that any cities where the percentage is starting with 4, the other digit is 2 and 9. So we know from looking at this that there's going to be cities that have 42%, or a city that has 42% of the population with an iPhone, and another city with 49% of the population with an iPhone. So it tells you the exact number, versus this is just telling you the number of cities in this interval. But notice here, if we just saw this table, we wouldn't know what the actual percentage of these two cities would be, right? It could be 41, it could be 46, it could be 47, we don't know. Over here, we do know the actual percentages. That's why a stem leaf plot is more detailed than a frequency table. And so we just keep going down the list. And usually what I like to do when I'm making these stem leaf plots is make a rough draft. So these numbers here, this 2 and 9, they have to be in order. So notice that they are in order. But a lot of times when you're going down the list, these numbers aren't going to be in order initially. And then at the end, I just like to put them in order. So let me show you. So let's find all the cities that start with 5. So we got 5 here. The last digit is 0. So we would put a 0 here. Then we have 58. So this here would be an 8. We've got 53. So we'd have 3. And then that is it for all of the percentages starting with a 5. So notice this is not in order, right? 3 is less than 8. So we would just switch the 3 and the 8 like that. And then all of the percentages starting with a 6. So we got 61, then we got 66 over here. We got 63. We got 67. We got 67. Now, if there's something repeating, notice how this 67 repeated, we would write that last digit twice. And then we'll have 62, so this would be a 2. And then we'll have 64, so we'll have a 4 there. And then we got 60, which would be 0. And then what we got to do is, again, put these in order. So it would be, I'll do it on the side here. We'll have 0, 1, 2, 3, 4, 6, 7, 7. And notice that there are 8 observations, 8 cities, which is what we got in the frequency table as well. Let me just double check that this is right. Yeah, looks right. So this would go here instead. Have them all in order. So we got 0, 1, 2, 3, 4, 6, 7, 7. Right? So the number here, the number of digits here should correspond to the frequency in the frequency table. Now with 7, notice that there was nothing here, so we would leave these blank. We wouldn't put a 0, because if we did put a 0, that would mean that there's a 70 somewhere here. Sort of like this 0 and this 0. We had the 50 and then the 60 for NYC and Seattle. So if it's empty, we just leave that empty. So there's no percentages that start with 7. There's no percentages that start with 8. And then this 9 here, we would put a 1. And so that right there is a stem leaf plot. Now, to generally explain it a little bit more, this right side here is called the, let me erase this here. This right side here is called the leaf. Now the leaf, I want to mention, is always going to be the single most right digit of your quantitative variable that you're looking at. Right? And then this here, this left side is called the stem. And it's going to be all digits to the left of rightmost, or of most right digit, of the leaf digit. Okay, so that explanation may have confused you a little bit, so let me clarify. Notice that all of these were 2-digit numbers, but what if we had data where we had 3-digit numbers? So let's say we had like 634 in the data, whatever it was, and then let's say we have like 512, and then maybe 7. We could even have 4-digit numbers. So let's say we had like 7,346. If we were making a stem leaf plot with this, remember the leaf is always going to be a single digit. It's always going to be 1 digit. So the leaf is going to contain these digits over here, while the stem, the left side, is going to contain all of the digits to the left of the rightmost digits. So basically all the other remaining digits, right? If we take out this rightmost digit. So the stems, notice that we're going to have 51, we're going to have 63, and then this one, there's 3 digits. We're going to have 734. And there's going to be all the numbers in between 51 and 63, and all the numbers between 63 and 734, which is going to be a crazy amount of stems, which is an issue, and we're going to talk about how to solve that issue. But for now, I'm just illustrating that this leaf part here on the right side is always going to be a single digit, while the stem is always going to be the other remaining digits. So for this 512 here, the leaf would be 2. And then for this 63, we would have a 4. And for this 7,346, the stem is 734, that leaf is going to be 6. Now let's say we had another observation with 518. Well, the rightmost digit is 8, and then notice that the stem is 51, so this 8 would go in this stem with this 51, so we'd have an 8 over here. So what this, if you were looking at this, what it would represent is that we would have 2 observations starting with 5 and 1, so we'd have 512 and 518. Right? If we had another observation, let's say another 4-digit number, 734, let's say 0. 7,340. Well, the rightmost digit is 0, and notice that the other digits remaining is 734, so that would go in this stem over here. And then this 0 would go before the 6. Remember, this has to be in order. So looking at this, you could tell there are 2 observations starting with 734, 7,340, then 7,346. Okay, so we're going to work in future examples with stem leaf plots that have more digits, and we're going to talk about again the issues if there are too many stems or if there are too little stems. We have different strategies that we can use for both issues. Now I want to finish off this video by actually comparing the stem plot that we made from this data to the histogram that we made in the previous video on the exact same data. So I redrew that histogram over here. And what I wanted to mention is we can actually get an idea from a stem plot how the respective histogram would look. So pretend that this wasn't here. What we can do with a stem plot is actually rotate it to the left by 90 degrees. And it's actually going to take the same shape as the histogram. So if we take this and we rotate it to the left, so notice that this vertical line here, it's now going to become a horizontal line. And then these numbers here, the numbers in the stem are going to go down here. So we're going to have 4, 5, 6, 7, 8, 9. And then what we could do is we could take these leaves and put them for those respective stems here. So we got 2 and 9, so we would just stack them. It would be like 2 and 9. Right? We're just taking this, rotating it to the left by 90 degrees. And then on the 5, we would have 0, 3, 8. For the 6, we would have 0, 1, 2, 3, 4, 6, 7, 7. For the 7, there's nothing. For the 8, there's nothing. And then for the 9, there's a 1 there. And so notice that this here, very similar to this shape. Notice that there are 2 cities where the percentages are starting with a 4, which is the same as 2 cities here, the frequency 2, between 40 and less than 50. And then the percentages starting with 5, there are 3 cities, right? 3 cities, frequency is 3. Now here, you're not gonna, the actual frequency number is not given, so you gotta count these, right? So 1, 2, 3, versus here, the frequency number is actually given. But just wanted to mention that, how we can get an idea of how the histogram is going to look by just taking this and then flipping it. And we could actually do the same thing here, get an idea of how the stem plot is going to look. We could take a histogram and we can rotate it 90 degrees to the right. And it's not going to give us these exact numbers, but it's going to kind of show us which stem is going to have the most amount of numbers. Because that bar, when we flip it, it's going to be sticking out more to the right for this interval, which would represent this row right here with this stem and then all of these leaves right there. Right, so that's the first thing. Now, I mentioned that there are a couple of issues that can arise when you're making stem plots. First issue is that stem plots aren't good for large data sets. Because if we have a lot of observations, making a histogram is fine because we can just adjust the scale here. Okay, so if the frequency, if there's going to be like thousands of data observations here, we can adjust this scale here on the y-axis to maybe go up by hundreds or thousands, and we could still make a histogram. Versus here with a stem plot, we can't do that. We can't adjust a certain scale. This is the absolute number of observations. And so if we had thousands of observations, then we would have to have thousands of leaves in the entire stem plot, which just wouldn't be plausible to make. So that's one issue with stem plots. They're not good for large data sets. They're better for smaller data sets like this. Now, even with smaller data sets, you can still run into issues with a stem leaf plot. And more specifically, there's going to be 2 issues that we're going to run into. But there's going to be strategies, fortunately, to fix those 2 issues. So the first issue is you can have too few stems. Too few stems. So what that's going to do is it's going to sort of scrunch the data. And it's actually really similar to the issues that we talked about in the previous video on histograms. This issue of too few stems is the same as the issue on a histogram of having too few intervals, right? Where the intervals are going to be too big. Each of them is going to be too big, but there's going to be less intervals. And so what's going to happen is that data we mentioned is going to be a little bit more narrow because there's going to be less intervals. So instead of having 6 intervals, there might be like 3. And what it's going to do is it's going to take these bars here and make them too high. We called it the skyscraper effect. So if the bars are too high, what that means is that frequency is too high. And relating it to a stem leaf plot, it means that too few stems is, as a result, going to give us too many leaves. There's going to be too many leaves here. Too few stems is going to be scrunched. So too few stems, too many leaves. Which too many leaves is the same as these bars on the histogram being too high. That's how they relate. So the strategy to fix this, it's called splitting stems, which is what we're actually going to do in the next video. I'm going to do an example where we run into this issue when we make a stem leaf plot, and I'm going to show you how to fix it using this strategy, where we can do something called splitting stems, which is going to make the stem leaf plot nicer to look at, better to analyze. Second issue is the opposite issue, where we're going to have too many stems. And as a result, if we sort of widen this data, widen this stem leaf plot, too many stems, it's going to cause us to have too few leaves in each stem. It's the same thing as making more intervals, too many intervals, so it's going to widen the data, and then these bars here are going to go down, so they're going to be too low. We call it the pancake effect. Exact same as this, as having too many stems, too few leaves. And to fix this issue here, we do something called rounding. We're going to have to round the data, so rounding the data. And we're going to have a separate video with an example where we run into this issue here, and then we got to use this strategy to make the stem leaf plot a little nicer. And so that's what we're going to cover in the next two videos. We're going to continue with stem leaf plots, but we're going to show you how to fix both of these issues.